Welcome to my lesson video on graphing and solving quadratic inequalities. Now let's get started. We are going to do 3 examples together. The first example is f of x is less than or equal to x squared minus 2x minus 8. Now if you have a graphing calculator with you, you can put this into the y equals part of your calculator, and then you can graph the points. Now, as you see, I've already actually graphed the points. I've already put it in my calculator, and I have graphed the points. That way, if you don't have a calculator with you, you can look at my points and plot yours from there. At this time, pause the video if you need time to plot your points. Now, when we solve an inequality like this, we are actually looking for more than just where is your line going to cross the x-axis. This is an inequality, so there will be a shaded region, and we know that our solutions can fall anywhere in that shaded region. After you plot your points, the first thing you will want to do is you will want to look at the inequality sign. Now I see that this one says less than or equal. Now the or equal part, that bar underneath, that means that my parabola or my curve will be a solid line. So let's go ahead and do that. And just do your best. Okay? Now that you have your solid line drawn, or your solid curve, excuse me, we have to decide where do we shade. One way to do this is to use 0, 0 as a test point. So if I'm going to use the 0, 0, that means I'm going to substitute 0 for the x and 0 for the f of x, because the f of x represents what y would equal. So I'm going to have 0 is less than or equal to 0 squared minus 2 times 0 minus 8. We know that 0 squared is 0. And we know that negative 2 times 0 is 0. Minus 8. So we would have 0 is less than or equal to negative 8. Now, is that a true statement? And no, it's not. 0 is actually greater than negative 8. So what that means is, since it is untrue for 0, 0, we cannot shade where 0, 0 would be. And we would shade opposite of that, which would be the outside. Okay? Now there's another method that I like to use, and I taught this to you when we did linear inequalities, and it works the same for quadratics. I go and I find my y-intercept, and I know, excuse me just a second, and I know that my y-intercept is at y equals negative 8. So you go and you put your pen or pencil on negative 8, and you look at the inequality sign. It says f of x, or y, is less than. Well, if you're looking at less than, that would mean going down from the y-intercept. And if you go down for the y-intercept, that means you are shading below. And then if you continue that shading, it would mean you shade on the outside. If it helps you, instead of saying y is less than or equal, you could say the shaded region is less than or equal. And that would make sense too. If your pen is on the y-intercept and you say the shaded region is less than, that means you would go down. So again, that's another way to know that you would shade on the outside. Now, we know that any solutions, any ordered pairs or points that fall in this shaded region are solutions, okay? But we can't show all of these solutions as interval notation. And so what we do is we just show what are the x values of all of the solutions. Now we can show that in interval notation. So let's go ahead and do that now. We are going to say that we start from negative infinity and we go all the way to negative 2. So that would look like this, negative infinity to negative 2. and you do put a bracket because it could actually equal -2. Now, we skip the space that's in between. We're skipping this, so we're going to use the union symbol. And after we do that, we pick up from here, which is x equals 4, and we go to the right to positive infinity. So that will look like this. Now let's do the second example. In our second example, we're going to use the inequality y is greater than x squared minus 8x plus 7. Now at this time, pause the video if you need to enter this into the y equals of your calculator, or if you're going to sketch the points that I have here. You can enter this in the y equals in a way that it will show you a shaded region. But my recommendation is just to use y equals and then use 0, 0 as a test point, or use the y-intercept test that I showed you in the previous slide. Because this inequality does not have the bar underneath, the or equal to bar, that means this will be a dashed line for my curve. And so here I would go. I'm going to try to do a fairly decent one here. And that means any solution that were to line or lie on this dashed line would not be part of the solution. Now all we have to do is determine, do we shade inside the parabola, or do we shade on the outside of the parabola? Now first I'm going to do the y-intercept test. And that is, I put my pen on the y-intercept, which is 0. And I'm going to say the shaded region is greater than. Now that would mean I go up. Now if I go up, is that going to be on the inside of this dashed line, or is it going to be on the outside? And it's very hard to tell given this, but it is going to be on the inside, which would mean that I shade all along the inside of this parabola. Now I'm going to use the 0, 0 test just so you can see both ways. So I'm going to substitute 0 for the x and 0 for the y. So 0 is greater than 0 squared minus 8 times 0 plus 7. And we know that 0 squared is 0. Negative 8 times 0 is 0 plus 7. So is 0 greater than 7? And the answer is no, it's not. Now let's think about this. 0, 0 is right here. And since 0 is not greater than 7, that means we cannot shade out here where the 0, 0 is. We have to shade on the other side of the line, which would be inside. Okay? So there's two methods there that you can choose to help you to determine where you shade. Now let's look at the third example. Okay, our last example is y is greater than or equal to x squared plus 9x plus 8. So now at this time, if you need to pause the video, you can, so that you can plot the points you see here or put it in your graphing calculator. Now, because it says that y is greater than or equal, that means we will have a solid line for our parabola. So I'm going to draw that now, solid line. And this one actually dips below your coordinate grid, I think because it goes down to negative 12. So you don't have to show that, or you can like I did. Now we have to determine where to shade. So I'm going to do the y-intercept method first. My y-intercept is up here where y equals 8. And so if I look at the first part, it says y is greater than or equal. So I can say the shaded region is greater than or equal to 8, and that would put it on the inside where I should shade. So that means I would shade everything on the inside. Now I will show you using the 0, 0 as a test point. Okay? So 0, 0, I'm going to also show 0, 0 on the graph. So that means I will substitute 0 for y. So I have 0 is greater than or equal to 0 squared plus 9 times 0 plus 8. 0 is greater than or equal to, well, we know 0 squared is 0. 9 times 0 is 0. So basically we're trying to say that 0 is greater than or equal to 8. Now, is that a true statement? No, it's not. So that means because it's not true, I cannot shade where you see the 0, 0, which would be all of this. I have to shade on the opposite side. So as you can see, using both methods to test, you would shade on the inside. On the second inequality, or the second example that we did, I forgot to show you how to do the solution in interval notation. So I definitely want to show you that on this third one. Now remember, this time the shaded region is in between the left and right side of the parabola. So if we're looking for the x coordinates of our solutions, they're going to lie right in here between where x equals -8 and where x equals -1. So this is how you would write that. You start out where x is equal to -8. That's why I have the bracket around it. And it goes to -1. And it can't equal -1, so you put a bracket. Well, I hope this video has helped you a little bit in understanding how to graph and solve quadratic inequalities, and I look forward to working with you again. Bye-bye.